Welcome, students. We are now back here with day 2 of week 3 of our e-learning. Again, we are just finishing up Newton's laws for today. We went over Newton's first law yesterday. So to get us going here with a few announcements that we remember from yesterday, guys, do not forget grades are currently being updated. I'll be doing, I feel, quite a few grades today here on this Tuesday. Unit quiz number 3, our third unit quiz so far. This e-learning quarter is going to start and be posted on Friday. Again, probably 10 to 12 questions. We're looking at that one. And then the Moon Phases Lab due on Sunday afternoon. Okay, so again, that was posted yesterday. You guys should have begun and started it yesterday, or hopefully some of us should have started it yesterday. All the details on that have been done on several posts. I had a number of students messaging me about accessing the document with the actual diagram with the analysis questions at the end of it. So I did directly message you guys with that document, as well as, because it was such a frequent question I was asked, I did post that document as well by itself on Edsby also, with some attached videos and documents that can also further help the original. So go ahead, check that out. Get going on that, guys, because again, that will be due soon enough. Before you know it, better to get ahead than fall behind, right? Okay, those are announcements for the day, guys. So let's go and get started on page 8 now. We're on a new Go Blue page. Number 1, what is the difference between acceleration and velocity? Went over those a little bit yesterday. And then number 2, what does Newton's first law of motion state? Pause. Go ahead, take a moment to think about it. I think some of the clips here, the GIFs kind of coincide with it. We've got inertia with the Newton spheres at the bottom. You may have seen that before. If we were in class, I'd be showing that. And it looks like a video game race car there as well, kind of showing that acceleration, that velocity a little bit, right? Oh, also keep in mind, guys, the notebook checks, those are every other week. So that'll be next Friday. All right, let's go to move on here. And to answer those questions, guys, velocity both have to do with movement, right? Movement, speed, things like that. But velocity is speed in a given direction. So whether it be north, south, east, or west, right? That's velocity. And then acceleration is the rate in which velocity increases, the rate in which speed, the rate in which, again, increasing or decreasing, in which, it changes. And then 2, for our Newton's first law, every object is either going to stay sitting still or stay in motion forever unless acted on by a force. Usually in our case here on Earth, obviously, that is the force of gravity. If I were to roll, say, a basketball or roll any sort of a soccer ball, it would infinitely roll forever. But because there's gravity acting on it, it's going to eventually stop rolling, right? And then again, inertia, that's the idea that again, things want to remain in a certain state of movement. So dominoes falling on each other, dominoes are going to want to keep falling until there are no dominoes left, right? We call that inertia. Any questions? Okay, that should be it for the Go Blue. Again, that's going to be on page 8. Oh, just another thing to add, guys, for your lab document, again, most of us don't have printers at home, so I'd recommend just simply rewriting the diagram and then answering your questions with that. Should be just fine. No problems there. Again, that's the diagram that's going to be illustrating the different phases of the moon. Okay, so with the moon phase stuff, we'll be starting that tomorrow with tides. So go ahead and add pages 8 and 9 to your table of contents. We're going to call those 2 different types of tides. We've got spring and neap tides. Again, we're going to talk about those tomorrow. Moving on from here, let's do our first practice question today. The aphelion is the farthest point from the sun in a planet's orbit. Is that A, true, or B, false? Take a moment to think about it. See what you guys have. The answer is going to be A, true, guys. A, true. Think aphelion away. Perihelion is going to be towards, right? But aphelion away, aphelion away. Again, orbit shape is going to be elliptical. And does the sun sit at the center? No, it does not. The sun's going to sit on one end versus the other. Orbits are always going to have farthest points and closest points. it's never going to be equal in distance all the way around, right? All right, so for Newton's second law, we're going to go ahead and go back to page, I think it was 6 or 7, probably page 7 to go over Newton's laws. Our second law is going to go over net force. So think of like a tug of war, right? The side that has the greatest net force being applied is going to get the greatest amount of pull or tug on the rope here in this instance, right? So when a force, again, make sure we write down what's in yellow, guys. This is his second law. Second law should be on page 7 or 8. We just got to go over 2 more laws, and then I want to talk about gravity a little bit. When a force F, again, remember that formula for force, acts on an object with a mass m, let me get my screen out of the way here so you can see it, produces an acceleration equal to the force divided by the mass. So again, A equals F over m, or F, more simply put, equals m times A. So that is the concept of Newton's second law of motion. Okay. So again, first law, stay put or stay in motion forever unless acted on by an outside force. But with second law, we're just talking about force itself. We're talking about what makes force. How large is something? How much mass does it have? And then how fast is it able to go? Again, if I get a basketball versus a bowling ball, the bowling ball is probably going to inflict more force because it has a whole lot more mass compared to the basketball, right? And that mass allows it to accelerate a little bit more as well. So Newton's laws classify objects as accelerating or non-accelerating, not as moving or as stationary. A good example here, it's too bad my little animation here isn't working. You can see on a roller coaster, right? So as a roller coaster goes up, it's going to be slow. Then as it goes all the way down the slope, it's going to be moving quite fast and then slow again. So a good example of that, where we get force from, all about mass with acceleration. To illustrate this on a little video here, let's go ahead and check out the first video, which is our tug of war example, using a horse versus 18 men in a tug of war. Who's going to win? Let's go ahead and check this out and see what the case is going to be. So, as you guys could see, and here's the second attempt. Funny because it looks like the guy, or skip the other video. Well, the guy in the red, he just could completely, was he moderating the tug of war? Because, okay, I think he was moderating. I'm like, this guy just totally gave up. He didn't even try. And as you guys can see, the 18 men were no match for the horse. And obviously, I'm thinking all these men here, they have much more mass compared to the horse. But the horse is just, I think, given the biggest advantage the horse has here is that it's able to accelerate at such a greater rate. And the horse, away with its forelimbs kind of galloping, is just going to be so much more force than men kind of like pulling back. It's not necessarily the most natural position to inflict the most amount of force from human bodies. So the horse nonetheless easily winning that matchup there. And then just to kind of show acceleration, right? Let's kind of see a Formula E car, kind of like one of those Indy race cars, versus a cheetah. Okay, so we talked about, let me see, I didn't want to skip ahead too much. Yeah, so let's go ahead and check this one out as well to see. So the horse beat the 18 men. Let's see who would win, a Formula car or a cheetah in regards to acceleration. Keep in mind, cheetahs are one of the fastest accelerating organisms in the world. So let's see, given a certain distance, can a cheetah still beat this Formula car? Let's check it out. And kind of a cool intro here. Race car driver, cheetah approaching at a standstill. All the good, cool visuals. And you guys will have to, I know, I have to be that person. You will have to watch on your own to see who wins that race. Save us time. I want you to check out my videos on your own. When you take initiative, I don't want to give away all the answers, but you will see here. Again, acceleration. Given the distance, the cheetah may have a shot. If it's a close enough distance, I think the cheetah could win. You saw right there. I mean, you clearly saw from the get-go the cheetah was winning. Had the strongest start. So who has the strongest finish? You guys can watch it on your own, and you'll find that out as well. Okay, so really cool stuff. Like I said, I always try to show cool videos. Do I not? I always try to. Okay, let's move on here, guys. Keeping my pace good, not stalling us one bit here. Moving on to our last law, Newton's law. So like I said, we talked about Kepler's 3 laws. Now we have Newton's three laws. You're going to see questions that are going to separate all these different sets of laws. We got to know these. All right, so only write what's in yellow, guys. For his third law of motion, to every action, there is an equal and opposite reaction. Or when one object exerts a force on a second object, the second exerts an equal and opposite force first. So kind of like when you throw a bouncy ball onto the ground and the ball bounces up high from the ground, or that little kind of the Newton's spheres I showed, where one metal sphere hits and the other ones react, and then the other one hits and it kind of careens. Or another good example is skateboarding. When you skateboard, okay, you take your leg and your leg lifts off the ground, and then it pushes off the ground, and it's gonna push that force and exert that force into the wheels of the skateboard, exerting you moving into a distance. Let's go ahead and check that out in real time. There's actually athletes who are professional longboarders, and they basically go incredible speeds, and they got these gloves on, they've got these suits on, because again, if they somehow lose balance and they fall off their longboard, they're going to see they could see some serious skin injury from the friction caused by the ground and them going off the board. And so again, they're going to only do this with the proper, you have to be professionally trained to do this, obviously, right? We just can't do this at home. But let's check out these amazing, incredible feats we see here with these professional longboarders using Newton's third law. For every action, there is a reaction, right? Really cool. It's downhill, no cars, obviously, so we'll save there. They're actually using those gloves to kind of act as kind of like a brake to slow down their longboard. We're making turns, as you can kind of see here as well. So really, really cool. I myself longboard, nothing to this extent, but I think adrenaline videos applying to science are always pretty fun and cool. So watch all of that and check that out. Maybe get a longboard yourself, get a skateboard yourself. Again, you got to start simple first, and just go on a flat surface and just kind of stroll around a sidewalk or a little parking lot. Really fun. It's a great hobby I picked up. I don't get to do it as much as I'd like, but definitely something that's just always good to get active and good to get the adrenaline going, for sure. So let's go ahead and talk about one more thing before we finish up for the day. Last question. Inertia is best demonstrated, again, through which scientific law? Think about what inertia is. Is it Newton's first law for A, B, Newton's second law, C, Kepler's first law, or D, Kepler's second law? Think about it. Which one had to do with inertia? Okay. And it is the idea that objects want to stay in one motion or sitting still. It's going to be Newton's first law, A. So that's how you're going to see questions maybe proposed to you on the quiz coming up here. Again, it's going to say Newton 1, Newton 2, Kepler 1, Kepler 2, right? All right, the last thing I want you guys to jot down on 6 or 8 whichever one. I'd say 8 actually. I was supposed to delete that 6, so we'll just put 8. What do we know about gravitational force? How does gravitational force act, and what kind of changes and determines how it's going to be? Well, gravity is attractive. Okay, gravity is what brought things close to the sun and vaporized a lot of different asteroids, brought planets together. But most importantly, it's going to decrease. Gravity decreases the farther you are from the sun. Okay, so if you're on, say, Mars, you are less drawn to the ground than you would be if you were on Earth, because Earth has more gravity, because Earth is closer to the sun. All right, and it increases as mass increases. So the larger the planet, the greater the gravity, right? So if Earth were to get twice the size that it is now, we would barely be able to stand on the ground. It would be pulling our entire bodies to the ground, and it basically walking would feel twice as difficult if the planet was twice the size. So here's another little example video I'm going to show you guys that really kind of illustrates that for us. This is the last video of the day. Don't worry, guys.
Twice as strong. So if you stepped would have 8 times change things. Well, first off, gravity would be very different. The Earth would have 8 times as much mass and gravity would be twice as strong. So if you stepped on a scale, you'd suddenly weigh twice as much as before. It would be much harder for you to walk and you'd get tired much more easily. After all, you'd feel like you were giving another version of yourself a piggyback ride all day, every day, which would look very funny. Over the years, human bones, especially in the legs, would have to become stronger to support this increased weight. Meanwhile, trees would start to collapse, and any new tree...
So just a lot of, hey, people would think, oh, planet's larger. Yeah, that's awesome. More Earth, more ocean, more land. It's a great thing. Not necessarily. It makes our whole way of living currently a whole lot more difficult. So again, watch all of that really cool, interesting stuff that I would have shown in class. All right, guys, so that concludes everything for today. Again, your moon phases lab. You got to label the moon phases here according to the sun's position and our position, right? You've got to answer these few analysis questions. What does waning and waxing mean? Waning moon, waxing moon. What does illustrate a solar eclipse and label? Illustrate a lunar eclipse and label. Again, guys, I posted another document that gives you a lot of hints, helps you better understand this as well. So good. You need to probably handwrite this, take a picture of it, turn it in by the end of the week. Hope you guys are doing awesome. I will see you again with another video. We are halfway done with the video lessons of the week. Again, we only do video lessons Monday through Thursday. Friday is assessment day with our quiz and our assignment turn-in. Keep up the good work, guys. Stay on track. Take care. Mr. Campbell, I'm going to go ahead and Mr. Campbell, signing out.